So, the course is designed for making understanding of the offshore structures for oil and gas exploration. Course number is OE 6200. Those who are new, of course, most of you are new except few students who are already in our curriculum. We will have two quiz 1, quiz 2. I think most of you will be familiar from the introduction session in SAC building, and there is a final exam. For this course, we have a division in such a way that 25 marks for first quiz, 25 marks for second quiz, and 50 marks for final. And if you look at the syllabus, first let us see the syllabus. I have divided the syllabus into 6 chapters, I would say. Each would carry equal weightage. So, if you look at this, we will try to cover the first 2 or maximum 3 before the first quiz, and that the questions will be from the first 3 chapters for the quiz 1, and 2 and 3 or maybe 3 and 4 will try to cover in quiz 2, and the remainder will be taken for final exam. But of course, final exam will have all 6 chapters together. So, that is how I am planning, and total number of lessons or the hours of teaching will be around 36 to 40, typically for a 3 credit course. Typically every week 3 hours class will be there. So, today we will be having 11 to 11:50, and tomorrow and day after tomorrow. So, 3 hours on Wednesday, Thursday, Friday is fixed, no change unless I inform you. This will be the regular pattern of the classes. Sometime we will have extra classes either on, depending on the slot availability, on Monday and Tuesday, but I think mostly we will stick to Wednesday, Thursday, Friday. So, you have to, most of these subjects, if you see the syllabus, I do not know whether you have seen the syllabus book which was given to you during admission time, bit of advanced mechanics. So, if you have background to basic mechanics, it will be easy to pick up. If you are not, go to the library, pick up basic mechanics book, start reading, so that when you are talking about few of these discussion in the class, it will be easy to follow up. Otherwise, you will find it little difficult, and many times you may not understand. So, typically you see this picture, the purpose of offshore structure, I think is a very good cartoon picture to see their idea behind why we build offshore structures, basically for the purpose of exploration. As you know very well, oil and gas is becoming in fact has become essential part of our life, without which I think every activity that we try to do requires some kind of energy, and basically oil and gas play a major role in addition to other natural resources. So, exploration of oil and gas is continuing forever until we complete it, that means exhaust it. So, you see here this picture gives you an idea. When you build a offshore structure for the purpose of exploration, we try to make sure that the revenue out of it is positive. Nobody is going to build an offshore structure for the purpose of just making nice design, because it is too expensive. So, the idea behind is we need to see whether the exploration is beneficial to the community. The idea. So, when we start working out, when we look at what type of structure is feasible or is technically feasible, economically viable, we need to put together the collective ideas and calculate the revenue behind, and basically the time frame by which you can get it back. You can get the revenue in 100 years, it is no use. So, basically you need to see the time frame. So, this picture shows offshore structure either underwater, subsea, we call it underwater structures, or conventional fixed structures on the right side you see there, which can be connected to the subsea structures for taking the oil and gas and then bringing by a pipeline to land. So, of course, we need to bring it to land for usage, and then it goes to a refinery. You see on the right hand side on land, wherein you see, so I supposed to show this like this. So, you see the refinery there, and then finally in the refinery you break down the hydrocarbon chain into usable products from kerosene all the way up to jet fuel of good quality, and then the subsidiary products used for even for road surfacing the asphalt is used. So, every chain small products are also used for this type of purpose. So, that is why hydrocarbon chain is highly priced item in the natural resource. So, basically you can see this picture gives you why we build a offshore structure, where it ends up ultimately we all want to make money. So, this gives you a slightly different perspective of how the oil and gas is produced. So, you see here in yellow color on the left side is called a platform to drill. Why do we build this platform? Basically for drilling into the seabed. Suppose if the same oil and gas is available on land, you do not need all this, you can simply go and drill using a bigger drilling machine, but unfortunately on almost all the land based oil and gas reserves have been exploited for the last 50-60 years. By the time now we have to look for offshore, means not available in onshore areas. You could ask why it is only isolated locations oil and gas is available, like if you go to Middle East or you go to North Sea, you go to US or some part of Europe and some part of India and some part of Southeast Asia. You see the isolated locations only oil and gas is available. Why not other locations? It is based on the history of the place, where the deposition of these material, basically the organic material decomposed into oil and gas for several million years. So, it is not that everywhere you drill you will get oil, it will be wherever. So, you have to look for. So, identification of these locations is a bigger subject, doing surveying, both remote surveys, magnetic methods or other methods which are economically feasible. Then finally, after identifying, you start drilling physical manner. That means, you will mobilize a drilling rig and drill to find out whether the oil and gas is available in that location. So, basically this platform, the purpose of building a platform, because it is in water, we cannot mobilize a drilling rig there. The reason we build this structure is to put the drilling rig on top of this platform, so that we can start drilling, reach the oil and gas resource below water, below ground. And you could ask, the depth of that could be few kilometers. Later will in the lessons you will come to know the oil and gas reserves are available not just 100 meters below like what you are taking water. We got to reach almost 6 kilometers below ground or below seabed. That is the kind of typical depth, 3 to 6 kilometers is the drilling depth that is required to reach these type of hydrocarbon deposits. And that means the drilling rig what we are talking about is not going to be a simple rig what you see on the land based drilling for water. You might have, most of you might have seen a mobile drilling rigs for getting water. I think most of the villages nowadays you will see them. They are very small, can reach as much as 100 feet, 200 feet, but what we are talking about is few thousand feet. 6 kilometer means you can imagine what type of drilling rig is required. So, that is why the structure that we design needs to have sufficient strength and basically also depends on the depth of water at that location. If it is 10 meter water depth, maybe you can build a very strong structure, but if it is 100 meter water depth, what will happen? The structure itself becomes vulnerable to the forces arising from the nature. So, that is why the design of offshore structures slightly in fact different from the land based structures. Number 1 is the water depth, number 2 is the environment. You see the environment is different from land, you have a different scenario there. You have water, you have sea waves, you have associated problems. So, we need to find out what are those problems and then design the structure for. So, if you can design an offshore structure, designing a similar structure on land is becoming as simple as that, very simple, because the environmental conditions are very easy compared to the offshore. So, that is where these structures purpose designed to drill or support drill facilities is called a well platform. Sometimes we call it drilling platform, you can call them either way, or you can call well platform, does not matter. The purpose for which it is built is to support the drilling rig and then allow the drilling to happen in a stable condition. So, you can imagine why not we do the drilling without this structure. Many times you are supposed to ask question, is not it? So, if you have a ship Why do we build this structure? Because ship can go there, do the drilling and come to another place, which can also be done. In earlier days, in 30-40 years back, the technology for station keeping of these floating vessels were not there. So, those days we have no other choice other than making a fixed platform, stable platform, where you put your drilling rig and drill. Whereas, nowadays when you go into a deeper water depth, say 2000 meter water depth, 1000 meter water depth, building a structure like this probably impossible. So, those kind of situations where we actually use a mobile drilling rigs. We will talk about it when we go into that chapter, how these drilling rigs make possible to drill when it is floating, because floating means it is not very stable, isn't it? That is what you can understand. If you have gone by a boat, you will realize how unstable, whereas this type of fixed structures is almost creating a ground, stable ground, wherein you put a drilling rig can drill without any trouble, as good as drilling on land. So, the purpose of building such a strong structure is to create such situation, because 1960s and 70s the technology for drilling itself is primitive. You do not have the machines of capability of that we have today. So, 30-40 years back it would have been so difficult to have any drilling, even if you have a movement of small amount, whereas now we have drilling rigs of different capability. 4th generation drilling rigs have such a capability, even if the ship is moving, can stabilize and do the drilling. The second, on the right side you see one platform where you see another structure standing there, which we have mentioned as a process platform. The reason behind building that, you could actually see later on these two structures could also be combined, but in this particular picture I have shown to be showing two different structures for the purpose of drilling and processing. So, when this drill fluid comes from the ground, it contains impurities, isn't it? It will have seawater mixing. Surely nobody is going to send you nice crude oil, isn't it? So, basically you will have impurities of seawater, probably sand content, probably particles of soil, and chemicals, unwanted chemical materials constituent part of the deposition. So, what we were trying to do here, you can transport the whole thing without any segregation, that means the whole thing to land, and you do a refinement of stage 1, stage 2, stage 3, stage 4. But what will happen when you try to do that on land? For example, you do not have this platform, you directly transport all the way to the land, the volume of transportation becomes larger, number 1, and then after you process on land, the disposal of unwanted material becomes a problem, especially the environmental issues related to disposal of these effluent from the refinery becomes a bigger issue. You have to take it back to sea and dispose of at a specific point, wherein it may not contribute to pollution to the life in and around that region. That becomes another problem, because you have to take it very far, because in the coastal areas you have habitants, you have marine life. So, that is why people have thought about, instead of bringing all the way here, why not we do some segregation offshore, some, not completely. So, we build another structure where we put equipments and facilities where you can take out the sand, very simple sedimentation process. I think most of you might have studied, if you are civil engineers, you have studied sedimentation process, no? By gravity the solid particle settles down. So, if you allow a longer time, a larger area to travel, the solid particles can settle down. So, this process what we are doing here is basically a very simple process by which you try to segregate the solid, fluid and gas, basically 3-phase separation, liquid, solid and gas. So, you have typical equipments in the industry, basically you pump it at certain pressure, solid particles will go down, seawater will be heavier than oil. So, seawater will also get at the bottom, and only the oil content will be floating on the seawater, isn't it? And then the gas will anyway go upwards. So, you can take it and then separate it. So, this 3-phase separation does not work, seems to be, is happening down there. The idea behind is reduce volume of transportation, reduce impact due to environmental conditions, because you bring everything on land, it becomes a problem. But then you can ask one simple question, why not we do everything here offshore itself, so that we get a direct fuel like gasoline. The problem is the refining, the further second stage refining on offshore, you need a bigger plant. So, you bring the whole refinery. Have you seen refinery when you travel around in many parts of our country? Even in Chennai, if you go north, you will see a big refinery. The refinery is large area requirement because of these various stages of breaking down. From crude oil coming from offshore, you first take out the primary products like gasoline, petrol, diesel, kerosene. Then it goes to second stage breaking down of all the secondary products. So, the equipments requirement, the storage requirement is too large, that if you want to build the whole refinery offshore, it may not be economically viable, and maybe it will take too long. So, that is why the stage 1 processing is done in offshore as minimum as possible, so that the transportation issues are resolved and then brought to the land. So, the whole spectrum of activities for any oil and gas project, you see here drilling and associated activities is happening down here, and then initial screening and removing impurities is happening on the process, and the third stage will be the offshore pipeline transportation system. You have to design them, you have to install them, so that it can bring the hydrocarbons to land. So, the whole process involves several disciplines, not only structures. You see here, it is not only just putting a structure, you are not getting oil, you have drilling systems, you have pipeline systems, structures, process, mechanical equipments. All this to operate, you need electrical power. So, you need a power plant, nobody is going to supply power. So, you have to produce your own power, that means you need to have a power plant on board, so that all the equipments can operate. You are not going to bring the power from land, that becomes too expensive. You cannot think of bringing a power from land and then putting a power cable. In some cases, in fact, it has been done, but normally we try to produce power on the particular platform wherever it is required. So, it is totally captive, no input is taken from land, everything is produced here and resources are exploited. So, ultimately at the end of the day, after doing this, you need to see whether you are able to get profit out of it, isn't it? Because you can do all that, and then the cost of investment versus cost of the revenue coming out of the project has to be positive. So, you see there one picture I have, that is what you will try to see. This picture gives you an idea of how much time and patience required for a typical offshore oil and gas field development. You need patience, because it is not one day activity, you go today and drill it, tomorrow you take the oil. It takes several years before you see money at all. So, you can see in this picture, from going to the site, going and starting exploration, exploration indicates that you are trying to figure out whether this particular area has oil and gas, isn't it? You have to do a lot of money spending to survey the area, several means are available. At the end of the day, if you are able to locate possible oil and gas reserves in that particular location, you do the drilling. The third stage is basically mobilizing a drilling rig, like something like what you are seeing on the in this particular picture. There you see a drilling rig, a jackup rig, basically drilling at that location. Once the drilling is done, then you take the samples, because you do not decide immediately, yes, I have got oil of some kind, whether it is usable form, easy to break down, or economically viable to bring it up, and the pressure, temperature, as well the properties of the constituent material. Then you do bring to the laboratory, do the testing and make sure it is good. Then only you plan for further activities of planning and spending more money on developing. So, basically this takes almost 10 years, and that is how the oil and gas projects are going on, unlike other projects on land, where most of the activities you may try to finish it in 1 or 2 years, 3 years if you start planning. But of course, nowadays even other projects takes longer time, 10 years, 20 years, 50 years. It is stalled because of other reasons, not because of this. But here physical nature of the type of project we are handling is a little bit of longer process, about 10 years. If you can get an oil and gas field developed within 10 years, it is very good. Sometimes there also lot of hurdles, not due to indecision in the process, but also due to some hazards in the drilling, hazards in the surveying. So, it can take a little longer time, but typically this is the kind of time frame that we are talking about. Once you see this blue line going forward, or the production is taking place, that is the time we are talking about cash flow positive, means all along we were spending, and that is the time that you start earning money. So, the typical number in a typical project is something like this. So, you could imagine, the reason I am showing this is to make sure that you understand the business, because the design involved here is high risk. Unless you understand that, you will never become a good structural engineer for design into offshore, because unlike land based structures, you do something, maybe nothing to worry, nothing will happen. Even if something happen, easy to remedy, whereas here things are very serious business. You make a mistake, has the largest impact. That is why you have to understand design of offshore structures is little bit tricky. So, once you see here starting to produce, so almost it takes about 15 years before you can break even into the cost, whatever you have spent you have taken back. So, that is the kind of business, and most of the time it is not going to be even that is going to be true, because while going through you will see that lot of expenses increasing because of changing scenario, because you are taking oil from below ground. You may actually expect initially very good production coming in, suddenly start reducing, you never know. So, typically is kind of high risk business. So, this basically, if you go back to this picture, we can divide them into 3 segments. That is what I am going to talk about, is upstream, downstream and transportation. So, the upstream what we are trying to do is drilling, associated activities and initial processing, means upstream processing, which is called the upstream production. You should not get confused with that. Production means you are not getting the actual oil and gas, is the crude oil is the production coming out of the upstream activity. The middle stage is the transportation, and downstream is basically the refinery on land, which will be able to see from the next picture. You can see there very clearly, you can see there the drilling brings the oil above water using conventional techniques, and then transported by a linking bridge normally. Sometimes we see in the oil and gas development you can actually have combined drilling cum production platform. Some cases where the water depth is larger, we combine them together to make one structure instead of 2 structures. When we make 2 structures, safety is a concern. Basically drilling platforms are high potential for accidents, that is why we keep them separate. But you could ask why in some cases we have a combined platform. Again we introduce additional safety there to reduce cost, because 2 structures versus 1 structure, one is definitely going to be economical. So, depending on water depth. And the transportation segment, basically most of the time instead of oil tankers we do normal transportation by pipelines, continuous. But in case of marginal field, for example, this oil and gas content is very small, sometimes we do have transportation by tankers instead of pipelines. And then the refinery does all our breakdown purpose into usable products, which you could see starting from high octane motor fuel, gasoline, petrol, and you have diesel oil, highly utilized in our country, LPG, jet fuel, refined form of petrol, added constituents, kerosene and other subsidiary products like fuel oil, lubricating oil, asphalt, coke. So, you can see every piece of the chain, hydrocarbon chain is utilized. In terms of gas, you have natural gas processing plant instead of refinery. In some cases, I think if you go to East Coast, we have got two big plants in Kakinada, where the Reliance have put up a big gas processing facility. Other than that, I think we do not have anywhere else. Oh, we have one more in Gujarat for the Bombay High gas processing facility. So, only very few. If you go to Middle East, you will find every country has several number of gas processing plants. Sometimes we convert the natural gas into other forms for transportation. So, this whole activity is downstream. Normally, we are not bothered because this is a conventional petrochemical industry, and on land. So, offshore engineers are not at all required to go there. Coming to oil and gas field development, you could see onshore, which was actually happening for several decades. Many parts of the globe, many countries were having onshore field. In meaning is you find oil and gas in the land, not land means below ground. So, basically for 30 to 40 years the exploration has been happening. In some of the countries nowadays, they feel that the reserves have reduced and basically moving to offshore. But if you look at India, we never had a very large hydrocarbon reserve on land, very few places, and that also have exhausted. Most of our oil reserves are in ocean. If you go to West Coast, mostly we find shallow water reserves, and that too almost exploited for last 40 to 50 years from 1960s. So, basic idea is in India we are also trying to move into deep water, means beyond few hundred meters. So, the technology is required, money is required. I think more than the technology, the amount of money required to spend. When you saw the shallow water development, I showed one picture previously, 500 million, it could become 5 billion. So, typically that is where the range of multiplication happening, 500 million for shallow water versus 5 billion for a simple deep water project. So, if you imagine the cost of the KG basin development is 12 billion US dollars. So, you could imagine, but after doing this, not enough gas, you might have read in newspaper. So, that is the idea behind deep water development, more than technology, because technology is available nowadays to reach even 3000 meters, whereas the investment required is too high. Very seldom people take that kind of risk. For example, you saw that graphical view of the cash flow versus production. For 10 years, you start pumping in 10 billion US dollars, you never know whether you are going to get back, isn't it? That is where the high risk business. But of course, success rate is also very small, 1 in 10. So, if you put 10 projects, maybe one project will be success. So, that is the kind of business. Sometimes you will find a lot of projects are coming up, sometimes very few projects, depending on. So, what is happening on this particular exploratory activities? We have a survey, we have exploratory drilling, and then the last stage will be design and development, which is a conventional activity like any other projects on land. So, the first two is basically a little bit of worrying nature, because the surveying will be larger area. It is not like you go to one place and start survey, you have to survey a larger area, few 100 kilometers. So, imagine you go to ocean, you take a 100 by 100 kilometers space given to this particular company for exploration. So, they have to do the survey in that kind of stretch. Once you do the survey, survey means various kinds, you find out what is the water depth, you find out what is the ground conditions, and penetrate the ground conditions by remote sensing methods to find the layers of soil, rock and below whether we have any natural hydrocarbon reserves depositions happened several thousand years. So, how do we do it? There are various techniques, remote sensing techniques to find out. You send a signal of particular kind, it could be seismic signal, it could be ultrasonic, or it could be acoustic signals which will reach and reflect back, and based on the strength of the signal received there are diagnostic methods by which you can decide whether it is oil or rock or other kinds of material. So, such techniques are well common and in fact, it is also used in land based techniques for surveying, remote sensing techniques. So, such methods are very suitable because most of the time we cannot even go to the seabed. So, floating vessels will be carrying all these equipments and can actually sense them. Once you find a kind of idea that there could be potentially such layers of earth's crust containing hydrocarbons, then you pinpoint the area, locate them and focus and do a more closer survey, whereas instead of 100 by 100 kilometers area, you may select 1 kilometer by 1 kilometer and try to pinpoint potentially higher possibility of availability of hydrocarbons. Once you do that, probably you are little bit positive, yes, something is available. Then you start looking for physical drilling, mobilize the drilling rig and then bring out the reservoir fluid and send to the laboratory, test it. Test means what you are trying to find out whether how much oil, how much water. Simple thing is too much of water, only little bit of oil, maybe you can abandon that area, I am not going there, whereas because the cost economic business will not work out. So, this exploratory drilling and estimate of reservoir fluid, how much is available? You could have oil, but only small quantity. So, how do we estimate this is actually a bigger subject. We have in fact our department, we have introduced petroleum engineering where reservoir simulation or there is a full course called reservoir engineering. This is not the same land based reservoir, it is underground void space in the earth's crust where it is filled with some kind of hydrocarbon fluids. So, we do have methods to estimate what could be the possible volume. Once you determine that, then probably we can go a little further to see that yes, we can invest further and spend more time, more money in developing the particular locality. So, in that we have several ideas depending on what is, whether it is oil or gas or mixture. You find out what processing required, identify the equipments, identify the structures, what type of structure is required and then prepare a report, make sure that your concept will work, and that is where a bigger role played by structural engineers. Depending on what is the type of oil and gas available, you play a major role because that is what is going to drive the total cost of the project, whether it is a fixed platform or a floating structure or some other type of structure. You will have to determine depending on what is the water depth, where is the locality, what is the environmental conditions, and then you finalize your design and then make an estimate of the cost. Then will determine whether based on that whether the locality identified is feasible or not feasible, because the other people have already worked out what is the amount of oil available, you have already worked out your structural concept, then put both things together, see whether the techno-economic feasibility is positive. If that is yes, then you will proceed further. So, typical jack-up rig, probably I think we will spend some time in one of the days. What is so called a jack-up rig and what is the great idea behind for drilling purposes? Basically, this you see 4 of skeletal frames sticking together. You see that in picture is the legs of the jack-up, where it will be positioned at particular location for drilling purposes. And you see here there is a boat in the vicinity. Basically, from one point to other point or one location to other location, these tugboats will pull these drilling rigs, because these rigs does not have propeller. So, they have to be taken from one place to other by pulling, but of course, has sufficient sea going buoyancy. So, it can float. A typical offshore structure you see here, we will have to introduce later on what is the purpose of this and how do we build this as we go along the course. We will see that later on, but you can see here this is a superstructure, it is a computer simulation, it is not a real picture, and a skeletal frame, 3-dimensional frame structure fixed to the ground by means of some sort of foundation. So, you got 3 components: superstructure, substructure and foundation. So, all 3 needs to be designed appropriately for the functional loads coming from all your drilling or from processing. This is a process platform, and then for the environmental loads arising from wind, wave and sea currents. So, that is where I think most of you are going through this hydrodynamics course. You will see that wave theory, hydrodynamics, wave loads, wind loads I think must have already learned in your graduate degree. So, you will see that these loads are going to be governing the design here in comparison to land based structures. Most of the time the loads are predominantly gravity loads, weight of the structures, is not it. Whereas, in here you see here the gravity loads are going to be small magnitude compared to the environmental loads, and the direction is exactly 90 degrees. The horizontal loads will cause huge bending compared to the loads arising from the superstructure. So, you see the shifting ideas from a land based structure to a offshore structure. The behavior of the structure will change, and that is how you are going to find difficulty in designing. Another platform structures where you see the larger area. See here in this previous picture, is a small area. So, depending on the locality, the requirement of the superstructure or so called the topside facilities may vary, and depending on that you see the substructure also becoming bigger. So, it is basically similar like any facility you build on land. Larger the facility required, your structure system also becoming larger. Typical reality of, you can see a drilling platform here, you can see a process platform here, basically built for that function, and on the right side you see here both of them are combined. So, you could see that potentially the water depth plays a major role. Of course, this is a very safe process. This is also safe provided you have a built in safety such that in case of an accident, fire and gas, basically you will have sufficient safety mechanism built in. Does not mean that this is unsafe, this is very safe. So, situation arises that this water depth, this is higher than this 150 meter water depth, building 2 more jackets may not be working out in that location, economically not feasible, whereas here water depth was less than that. So, not a big problem. So, where do we call, see here a group of platforms for function wise. One could be a living platform, you see here on the left, far left here is a platform for purpose built living facility. To operate all these equipments here you need people, it is not going to be everything is remote control. So, basically the idea behind is you segregate that away from the facility that has got hydrocarbon, number 1, high risk of fire, high risk of blast sometimes, and the facilities are segregated. This is a drilling platform. So, you can see that sometimes we do segregate this way to avoid a chain reaction of accidents, basically, and this is the most safest place because it is very much away from the hydrocarbon facility. So, you will see that if you go around any offshore field, many times you will see that colony of structures, few of them, group them together, so that one by one will do a different function. So, in summary, in this course what we are going to look at is, primary purpose of this course is to design fixed offshore structures only, because later when I think some of you might go into this OE4, we have a special subject called the design of floating offshore systems, which will come in third semester I think. So, there we will cover the design for floating systems, similar, but of course, the idea is slightly behind. Floating systems are different, but the purpose for which it is designed is same, you know. So, in this particular course we are going to focus high on fixed structures and associated component design. So, offshore structures subjected to high wind, high storm wave heights and sea currents. Water depths, almost the structures that has been built in the last 3 decades, 600 meters water depth. Some of the fixed structures have been built in Gulf of Mexico. Water depth in excess of 3000 meters in case of floating structures. Operating temperature is also a concern. As you can see, when it becomes low temperature, the behavior of steel becomes different. So, what will happen? It becomes too brittle. So, the same structure built in conventional shallow water, say less than 100 meters, may be subjected to a temperature of 15 degrees, 10 degrees, whereas if you go to 500 meters, the temperature goes down as much as 5 degrees. So, at low temperature, steel becomes potentially vulnerable for cracks, potentially vulnerable for failures, and you are installing the structure in seawater, highly corrosive. I think most of you might be familiar with seawater corrosion. So, when you put a structure like that, what you saw in the picture, you need to protect them against seawater corrosion. Otherwise, after few years you will see that. I will show you some pictures later on, even the protected structures, how badly they corrode, you know. Maybe tomorrow class I will bring the pictures. A recent survey taken 2 weeks back shows that some of the areas, even after protection, you see a high corrosion, some of the structural members are dislocated, failed, and then the last one is basically the loading is cyclic. As you can see from if you have gone to beach, you will see the wave action is dynamic, isn't it? All of you have gone to beach, no? After arriving in Madras here? No, maybe you can see one of the days. You can go there and you can see how dynamic is the sea waves. So, you could see one by one is an added effect. So, if you know how to design a structure on land, so you add all these 6 factors in addition, you will find it quite tough to design, and each one area is a specialized area. For example, if you take a fatigue, you need to understand what exactly is happening and try to mitigate that problem. Similarly, the low temperature, corrosion. So, each one is actually a subject itself. You know, if you look at if you go to library, you will find so much of material related to each of the subject. What we are going to do in this course is to condense a little bit of introduction and bit of calculations to understand how the problem can be approached. So, further reading, further practice at the end of the day is required by everybody, so that you become familiar with the subject. What we are going to learn is probably 1% of each. We are not going to cover, we cannot cover in this one 40 hour course that the elaborate manner. Of course, we will give you a little basic, so that you can read further on the subject. So, you see sometimes the sea conditions are so rough that even water is splashing onto the superstructure. These structures were built earlier, several decades back, but the sea conditions changes. You might have heard this term called global warming, isn't it? So, what is happening? The ice melting, seawater level rises, sea condition changes, and there are several other natural phenomena where climate conditions are changing from time to time, and you see a storm in non-stormy conditions, cyclone in a regular normal period, which is not so good. So, things are changing. So, that is why the structures built earlier, say 30-40 years back, are subjected to different kinds of loading, because we never expected the waves to be so high, because those days the knowledge on sea wave conditions were so limited. So, we just assumed several things, but you can see things are becoming more and more vulnerable. And the structures in comparison, I think you should realize when you see the picture, the structures are not so small, structures are very high. For example, you compare a 100-meter water depth jacket is as much as 30-40 story building, but imagine a 600-meter water depth jacket, it could be taller than any of these buildings. So, the structures are taller, slender and limited by its own size and shape and subjected to severe environmental conditions, and loads are placed at the top, unlike other building structures where the loads are uniformly distributed. When we go to dynamics, you will see that the concentrated loads on the top could make potentially difficult to design. So, you see that the idea behind needs to be understood, and the foundation system for this needs to be installed, constructed and installed in offshore conditions rather than nice ground conditions like this building. You dig around very easy, no need to worry, whereas the whole thing is to be done in a several kilometers inside offshore and start building. So, every aspect what we have seen in the previous slide is only the design aspect, but if you look at the construction aspect, you will really get little bit worry because everything is so difficult. I think we will stop here.